in this example, you're being asked to identify all of the components of this SN2 reaction. You need to identify the nucleophile. You need to identify what is the nucleophilic atom of that nucleophile. Then you want to identify the substrate, and then you want to identify what is the leaving group of that substrate, as well as which carbon of the substrate is the electrophilic carbon. And that's everything you should evaluate when you're looking at an SN2 reaction. So let's just start with this one here. So we'll start with this species on the left here. This is the substrate, okay? This is the species bearing the leaving group. So the leaving group in this scenario is chlorine, okay? Let me draw this out a little bit differently. So here we have our carbon. It has 3 hydrogens bonded to it, and it also has the chlorine bonded to it. The chlorine is the leaving group of the entire substrate. The electrophilic carbon of the substrate, this one's easy because there's only 1 carbon in there. It's always the carbon bonded to the leaving group. So the electrophilic carbon is this carbon that I'm putting in red. Okay. Now, that means the other species in here, this is the nucleophile. That's called sodium methoxide. Don't worry about the name. I'm showing sodium methoxide. I'm showing the cation there. It's not always going to be shown, but it's there. So in this scenario, what's happening is you have something nucleophilic on here. And remember, a nucleophile has a buildup of negative charge. Okay, so that sodium methoxide, we're not really too concerned about the actual cation there, sodium. What we're really concerned about is the component with the oxygen, and that methyl group is just bonded to that oxygen. But more importantly, that negative charge is built up on the oxygen. So this methoxide is the nucleophile. The oxygen is holding that negative charge. That is the nucleophilic atom of the nucleophile. Okay, so we've identified each piece that we're asked for, but since we're here, let's just go ahead and predict what would the actual product be. Well, we know that the negatively charged electrons will do a backside attack on the carbon. That just means approaching opposite the leaving group. When that oxygen bonds to that carbon, it simultaneously kicks out that leaving group, which means we will then have, let me draw all of this out. We will have that carbon bonded to that oxygen, which is still bonded to this CH3 group, plus that chloride. I'll draw all the electrons in here. That chloride would be the leaving group.